Hi everyone. I want to address the topic of standard deviation because I have gotten a lot of questions about this, and I kind of want to show you guys an easy way to do it. Now, the big standard deviation problem that we were given is in lesson 2.4.1, which you can see the first page here of the Take It Home, problem 1. So in that problem, you're asked to take the standard deviation of all of these women's ages. To do this, let me first remind you of the formula of standard deviation. So we have S for standard deviation equals the square root of the sum of all of the data values when you minus the mean. So x bar is the mean. You square these deviations, and then you divide by n minus 1. So let me review the symbols here. So remember, x bar is the mean, and we're given the mean of 22.1. So we're given the mean of 22.1. Remember, n is the number of data values. So if you look at the problem, we have 43 data values, so 43. So really, the standard deviation can be divided into a few parts. So first, for each data value, we have to have the deviation. So that's the deviation from the mean, the data value minus the mean. And then we square it, so we square the deviation, and then we sum it up. We add up all the deviations, and then we divide by the number of data values minus 1, and then finally we take the square root of all of that. So what I'm going to do is make a little table that will help us solve this problem. So first we have the data value, then we have the data value minus the mean, then we have the data value minus the mean squared. We add that up, and that's it. So let's get going. So first we have 25. Then we have the next column would be 25 minus 22.1, right? And if we put that in a calculator, 25 minus 22.1, we get 2.9, right? And then we have 2.9 squared. 2.9 squared is 8.41. So what we've done is we've finished the first row that we need to do, and let's do the next row too. So the next data value is, we've done 25. The next data value is 24. So I'm going to put a 24, and now we have 24 minus 22.1. So what is that? That's 24 minus 22.1, and we get 1.9. 1.9. And we square the 1.9, not square root, but square. We square the 1.9, and we get 3.61. Okay, now I'm going to pause and finish the rest of the numbers that we have in the table, and then I'll show you how to do the rest. Okay, so now with great effort, I have filled in the rest of this table all the way from the first data point of 25 to the last of 22. And you can see it over here all the way down to here. Now what we have to do is sum up all of the numbers in in this column. So all the way down to the end over here. That's what we have to add up. Because in the formula for standard deviation, we have the sum of x minus x bar squared. And if we add up all these numbers, we get, what do we get? We get 684.12. Now, if we recall the formula for standard deviation, you can see that we have to take this sum and divide by n minus 1 and then take the square root. So that's all we have to do. So we take 684.12, divide by n minus 1, and what is n minus 1? Well, that's 43 minus 1, or 42, and take the square root. So if we do that, we will get a final answer of 4.0359. I'm going to go ahead and round to 4.04. 4.04. And that's the answer to this problem. So it was a lot of work, but the idea is that all you have to do is do the standard deviation by hand one time. And then for all the rest of the times you do it, you can use a computer. So I'm just requiring you to do it by hand once.